Hey math kids, today we're going to talk about simple rules of differentiation, and differentiation is just when we take the derivative of a function. And so for the first one, they want us to find f prime of x when given f of x. And the first f of x we have is this. Now in the previous videos, we did this from first principles, but in this section they're going to let us use the shortcuts. So what the shortcut is, if we have a polynomial, we take the power of x, we bring it down in front and multiply it, so we get 15, and then we reduce the exponent by 1. So we take this, bring it down, multiply, we get 12, reduce that to a 1, so it's just x. This is like a 1, bring it down, multiply, so that ends up being -3, and then constants go to 0. So this is our derivative, and we can move on to the next one. Okay, this one's going to be easiest if before we take the derivative we rewrite it. So we're going to use negative exponents. And then we're going to use that same algorithm. So this is 1, bring it down, multiply, just 7. That turns to a 0, so the x goes away. Bring the 1 down in front, or the -1, that becomes +4. Then reduce it by 1, so it's -2. Take this, bring it down in front, and -4. Now, we want to write it back in this notation. So it's going to be 7 plus 4 over x squared minus 9 over x to the 4th. Okay, we'll keep going. So now we need to find the gradient function or the slope function, which is really the same thing, just asking us to find the derivative. Just like the previous problem, we want to rewrite this. So we're going to write it as 3x to the 1/2 plus 2x to the -1. And then from here we can just use that simple algorithm, bring this down in front. So that's going to be 3/2 when we multiply that. Now when we reduce this by 1, 1/2 minus 1 is going to give us -1/2. And then bring this down in front, so that's -2. And then -2 up there. And if we write it back in the notation that we started with, we're going to have 3 over 2. This will come down to the bottom, and so it's the square root of x on the bottom. We have 2 over x squared for that one. Okay, the next one. Once again, we just rewrite it. So x squared is fine, but this is going to be x to the -1/2. Negative because it was on the bottom, and 1/2 because it was square root. And then we just get 2x plus 4 times 1/2. The negatives turned into the positive. And if we reduce that by 1, it's -3/2. Multiply those together. We get 2x to the -3/2. And in most cases that's fine, but I'm going to take it a little bit further. So we can do 2x plus 2 over x to the -3/2, which is going to give us 2x plus 2, oh not negative, that's positive. And then this would be x cubed under a square root. And so if we break this up into x squared and x, and then x and x, a pair of x's come out, we're left with x root x. Once again, I'll accept it at this point, but that's how you get to what your book has written in it. So it says find the gradient of the tangent to this function. And where x equals 2. Alright, so we're just going to go through the same process we've been going through. So we rewrite it like this, do the algorithm, and then this is our y prime, or our derivative function. I'll rewrite it as that. And now the extra step is we just need to plug this in to both those x's. So 2 times 2 plus 4 over 2 squared. So that's going to give us 2 times 2 is 4. We get 4 over 4, 4 plus 1. And so that is the gradient of the tangent to that line, to that curve. Okay, last one. Y is equal to 3x squared minus 4x. It says find dy dx, which is just another way of saying find the derivative. And then they want us to interpret the meaning. So we go through the algorithm, bring the 2 down, we get 6x minus 4. Okay. And this is a function that will tell us the slope at every single point of this function. So once again, this tells us the tangent slope of every single point on this function. If you need additional help, come to Math Lab. Until then, calculator.